All right, so let's go ahead and take a look at this problem set. So I don't care how you guys solve your system of equations. So you can use elimination or you can use substitution, whatever is the most convenient. So when I look at what's most convenient, like if I look at problem 1, even if I look at problem 2, one of the variables already here in problem 1 is already isolated. And here in this problem 2, it's very easy for me to isolate one of the variables as long as I'm willing to work with fractions. So it's completely up to you. You can move, your 5x over to the other side, and you can move your 10x to this side. I'm sorry, I shouldn't move the 10x. I should move the 2y to this side, and then use elimination. But because I already have my y isolated here, I would probably just use substitution. So my 10x is equal to 2 times my y, which is 5x minus 1, and then plus 2. So 10x is equal to 10x, I'm distributing, minus 2 plus 2. Oh, interesting. So I get 10x is equal to 10x, which means that 0 is equal to 0. So remember, in these situations, when I get 0 is equal to 0, or something that's true, like 10x is equal to 10x, then this is infinitely many solutions. Remember that if I get something that's false, right, then that is no solution. So if I get something where like 5 is equal to 7, which is not true, then I would get no solution. Okay, so now for 3, I would kind of like to see you guys try to explore what you're supposed to do. And I don't want to necessarily, give it away because and show you what I would do and give you the exact answer, because I want you guys, part of the idea behind this is that we're doing this one in class. And so I want to kind of see how you guys are discovering this. But, one equation in the system is this equation here. Okay, so to write another system so that it has one solution, you just don't want it to have the same slope. Okay, so I don't want same slope. And then for no solution, remember, no solution means that we have parallel lines. And so that means that it's not the same line, but they have the same slope. Remember, parallel lines have the same slope. So I want you to write me an equation that does that. And then infinitely many solutions. Remember, infinitely many solutions means that it's the same exact line. So it is the same exact line. But maybe what we did is we multiplied both sides of the equation by like 5, for example, or a different number, okay? So that is your problem 3. When I look at problem 4, and I know it's an even question, but, when you're trying to do these, you want to look at all the information, 142 total people, 6 drivers, 2 types of vehicles. The bus holds this many. The van holds this many. So what you want is you want to create 2 equations with 2 variables, okay? And then you want to be able to solve. So now if I look at, I'm going to look at 6 before I look at 5. Again, because it is an even one. Describe and correct the error. So again, I'm looking at this and I'm trying to figure out, like, where did the person make the mistake? And then what I want to do is I want to go back and actually take the equations and I want to solve. Okay, so I want to take this system of equations and I want to actually solve it the correct way. So it is a 2-part thing with error analysis. Okay, so let's see. So in a talent show of singing and comedy acts, the singing acts last 5 minutes long and the comedy acts last a total of 3 minutes long. So 5 times the number of singing acts plus 3 times the number of comedy acts equals, now notice, minutes and minutes. So I need the one that has minutes. So that gives me 50. Total number of acts. So remember, S, I said number of singing acts times 5 minutes, number of comedy acts times 3 minutes. So S and C, so S represents the number of singing acts And C represents the number of comedy acts. So my first equation relates minutes together, total minutes. Now my second equation is going to relate the total number of acts. So I cannot use X because I changed my variables. Okay, so S plus C is equal to total number of acts, which is 12. So this is number of acts. And then I want to go ahead and not only, so I wrote my equations here, but I want to go ahead and figure out how many singing and how many comedy acts are in the show. So again, like I have, change colors here. So I have 5S plus 3C is equal to 50, and S plus C is equal to 12. So I can use elimination. I can use substitution in this case. The only time I really wouldn't use substitution is if I was going to have to deal with fractions. So if any time I had to deal with fractions, I probably would avoid that and not use substitution. But here I could take my bottom equation. It doesn't matter. Eliminate C, eliminate S. I could eliminate S by multiplying both sides of my equation by -5. So I have 5S plus 3C is equal to 50. And then I have -5S minus 5C is equal to -60. So then I add vertically, so I get no S's. All my S's go away. And then I'm left with -2C is equal to -10. Divide by -2. And I get C is equal to 5. Notice, if I would have gotten a negative number, then I would have had a negative number of comedy acts, which does not make any sense whatsoever. So you have to be very careful that you are solving it, and it makes sense with the problem. Okay, so if C is equal to 5, then if I have S plus C is equal to 12, and S plus 5, which is the number of comedy acts, is 12, then I can subtract both sides by 5, and I get S is equal to 7. So it's not just about the actual variable answers. You have to actually write this as an actual sentence. So there are, let's see, how many? 7 singing acts. Oops. And 5 comedy acts. Okay, so make sure when you do word problems that you're actually identifying or answering the question that's there. Because it just doesn't make any sense to write this as a coordinate point because we're not actually graphing anything. We're actually trying to solve number of singing acts and number of comedy acts. So I do want it to be in a complete sentence. Okay, and that's it for this section.